Page 10. So these are double and triple bonds, and you know it by the ending that they're going to give you. So enes means you have double bonds, at least one. Yns, YNS, means you have a triple bond. So this gets built into the name of the compound. We call these because, so remember we said if all the it's just carbon and hydrogen, there's no double or triple bonds, we call them saturated. All right. If you have double or triple bonds, they are now unsaturated molecules. All right. So because they are unsaturated, they have low melting points and boiling points. So you've heard of saturated fats and unsaturated fats. Which one's bad for you? Saturated fats. The reason saturated fats are bad, saturated fats are just long strings of carbons. You don't have to draw this. Saturated fats look like this with the hydrogens on them. And because they're linear, they stack like this. They can get really close to each other. And then they solidify. And then that's what blocks your arteries and all that, and leads to heart attacks and all that kind of stuff. Unsaturated fats have double and triple bonds, and you're going to see in a sec here that they create these isomers. So because you lock them into place, you get these different structures depending on how many double bonds and triple bonds you have in there. So they can't stack together as well. That's why they have lower melting points and boiling points, all right? So they don't clog up your arteries as much. Look, if you eat a ton of unsaturated fats, probably not good for you either. But that's why saturated fats are bad, because they can clog together. If you look at certain oils that solidify at room temperature, those are usually saturated fats, all right? If you look in your pantry at home, and the ones that are usually liquid at room temperature are the unsaturated fats in general. Okay. They have isomers. We'll talk about that later on, but let's get into the naming. So, single bonds, it ends in A and Y. That's what we've been doing. Alkanes, all that kind of stuff. Double bonds, we get ENE and ENE, and triple bonds, YNE. All right. So, how do you name them? The double bond takes precedent, or the triple bond takes precedent. So you start your numbering so that you have the lowest number on the double or triple bond. Okay. So if we look at, save that one for a sec. Let's look at this one right here. 1, 2, 3 carbons. 3 carbons is what? What's the prefix for 3 carbons? Propane, right? Propane would be the normal 3 carbon saturated one, but we have a double bond. The double bond, you always start labeling so that that has the lowest number. So we're going to label, can't write in, 1, 2, 3. And because it's a double bond, we don't say propane, we say propene. All right? Now, you don't put the 1, you don't write 1 propene, right? If there's only one bond, double bond, and it's on carbon 1, you don't have to put the 1. So you would just say propene. All right? So it's assumed that it's on 1. Same with this one. 2 carbons is what? Normally, 2 carbons saturated would be what? What's the name? Ethane, right? 2 carbons is ethane. It would normally be ethane. But because we have a double bond, we change it to ethene. And you don't have to put the 1 because there's only 1 carbon it can be on. All right? All right. Now, triple bond, big complex molecule. Look for, yeah. because you haven't. You'll see when there's multiple double bonds, you have to put the carbon that they're on. So if it only says propene, you know it's on the first one. There's only one. But if there's multiple, you have to build that into the name. We'll do that on the back page, basically. All right. So look for the longest chain. What's the longest chain in here? And you have to include the triple bond. Is that it? 1, 2, 3, 4, 5, 6. That's what I would get. Okay. So longest chain is 6. You always start numbering so that the double or triple bond has the lowest number. So we have to call that 1, 2, 3, 4, 5, 6. So we have functional groups attached. What is this group? What do we call that? Sorry? That's a methyl group. All right, 1 carbon. And then the other one we have is this, which is, I want to do that. 2, so that's a ethyl group. Okay, which comes first, ethyl or methyl when you're naming it? Ethyl, you go alphabetical. Ethyl is on carbon 3, so we're going to call this 3 ethyl, 4 methyl, and then you have to put the carbon that the triple bond is on. Which carbon does the triple bond start at? Number 1, right? So then you say 1, it's 6 carbons long, so that's a hex. But because it's a triple bond, it's not hexane, it's not hexene, it's hexyne, Y-N-E. So it becomes 1 hexyne. And this 1 tells you where the triple bond is. So 3 ethyl, 4 methyl, 1 hexyne. All right. Cyclo compounds can have double or triple bonds as well, depending. All right. If there's only 1, you don't have to number it because you always start at the carbon with the double bond, right? So if we're looking at this, carbon 1, does it matter which way you go? You have to go in the direction of the double bond, right? You'd have to go this way. So if I start here, I go 1, 2, 3, 4. If I started the other way, like here, 1, 2, 3, 4. So that methyl group's still on carbon 4, no matter which way you go. Does that make sense? Okay. But if you start on the carbon, well, you have to start on the carbon with the double bond. You have to follow the double bond. You can't go this way. You can't go 1, 2, 3, 4 like that. You have to follow the carbon, the double bond. So no matter which way I go, the methyl group is on carbon 4. So this is going to be 4 methyl. Now, if there's only 1 double bond in the ring, you don't have to number it because you always start numbering on that double bond. So you don't say 1 cyclopentene, you just say cyclopentene. So it's 4 methyl cyclopentene. Yep. Sorry, what? This one? This one? Do what? Oh, why did I say 1 hexyne? Because you have to distinguish which carbon it is here, and we have to number them anyway to get the methyl and the ethyl groups. Because if I just said hexyne, it could be like you could have the double bond between 2 and 3. So you have to indicate. But when you're doing a cyclic compound, you're always going to start numbering there. All right, now we're going to draw it. 4-methyl-2-pentyne. So pent tells you how many carbons? 5, right? So you can draw out 5 carbons. So are we talking about a double or triple bond here? Double or triple? Triple, because it's YNE. Which carbon is the triple bond on? Carbon 2. So it doesn't matter which side. You just pick a side to start numbering from. So carbon 2, I'll just say this is it, has a triple bond. So you put a triple bond in. Carbon 4 has a methyl group. So if this is carbon 2, if that's 1, that's 2, 3, there's 4 right there. It's got a methyl group. And then you just have to fill in all the hydrogens around it. So N is going to be CH3. This carbon 4 needs 1 more hydrogen. These 2 carbons here with the triple bond, do they have any hydrogens on them? No, because carbon wants 4 bonds, right? So it's got 3, 4, and that one's got 3, 4. And then this end here has, 3 hydrogens. If you did it with the skeleton method, it would be boom. 1, 2, 3, 4, 5, like that, and then carbon 4, 1, 2, 3. You could put a CH3 there, or just put a line up, but that's what it would look like. Okay. Are we okay? Yep. You can do whatever you want. Yeah, I don't care. If you like the skeleton, that's usually the fastest way, but I'll try to, when I'm getting you to name them, I'll try to draw them. I'll draw them like this. Okay. Unless it's a ring, because rings tend to be easier to draw with the skeleton method. All right. 4-methyl-1,4-hexadiene. So, hexas, how many carbons? 6. What does the diene mean? 2 double bonds. And that's why the 1 and the 4 is there. So, you can draw out your carbons. 3, 4, 5, 6. On carbons 1 and 4, we have double bonds because it's the ene. So double bond, 1, 2, 3, 4, double bond. And on carbon 4, we also have a methyl group. And then everything else is single bonds and hydrogens. So H3, 1, 2, single bond there. Let's stick a hydrogen up. Bond, bond. H up. So look like that. If you wanted to draw the skeleton method, it's hexa. 6 looks like that. Carbon 1 has a double bond. 4 has a double bond. And 4 also. 1, 2, 3. Oh. 4. And this one also has a methyl group. That would be the structure in the skeleton method. 1,3-cyclopentadiene. Penta and it's cyclo. You're drawing a 5 carbon ring. We have to put the 1 and the 3 because there is 2 double bonds in it. So if you call that 1, 2, 3, there's a double bond there, and there's a double bond there. Sorry? Yeah, and generally you do it on the inside. I guess you could put it on the outside. It's not wrong, but in general, you do it that way. 4-methyl 1-pentyne. How many carbons? 5. And we have a triple bond on carbon 1. So, and carbon 4, we have a methyl group. 1, 2, 3, 5. So you get that, 4, 5. Yeah. There, it'll look like that. There, that would be the skeleton structure. And the last one, 1-chloro 1,chloro-1,3-cyclopentadiene. So basically, this is the same as right above it. There's the 1,3-cyclopentadiene that we just drew above it. On carbon 1, you have to put a chlorine molecule. That's the only difference. And that's it. Okay? Does that make sense? So we just added in, you're just changing the ending of the parent molecule, or the longest chain, to ene or ine. If you have 2 double bonds, di or tri or whatever if you have 3. 228, 23, 24, and 25, please.